To construct a URL for the iTunes Search API, we need to be good citizens and encode our URLs, particularly our search term, since that's an empty field where the user can enter any input. Now, what does encoding mean anyway, and how do we do it? When creating a URL, or URI to be more generic, there are a set of reserved and unreserved characters. For example, all of the following are considered unreserved characters. Now, unreserved characters are safe to use and do not have to be changed to anything else in a URL query string. The following, however, are reserved characters. A reserved character is one that has a special meaning in a certain context, and this means we can't use it as is, but instead we need to %encode it. %encoding a reserved character means converting the character to its corresponding ASCII value represented as a pair of hexadecimal digits preceded by a %sign. This means that each of the following reserved characters, after being encoded, would look like this. There are some additional reserved character considerations to be made depending on the part of the query we're encoding. For example, in a URL path, we typically use the / to denote different path segments. If there is a / within a path segment, it also needs to be %encoded. However, a / in a query component doesn't really mean anything, so it doesn't necessarily have to be encoded. Now, in addition to the reserved character list, we also encode characters like the angle and curly brackets because they're used in passwords. In practice, since there are many different cases, the default approach is to %encode all characters that are not unreserved characters. Let's see if we can write a series of functions that iterate through any possible parameters we would add to a query string and encode it for us. Now, for the purposes of this exercise, let's go ahead and create a new playground, and you can save it in the same folder here. We'll call this URL encoding. Hit next and save it in the same place as the iTunes client project. Let's close this out and max out the window. For this course, since we're only going to be creating a query string with parameters, we're going to focus on encoding the query. To do this properly, we'd have to look at encoding different parts of the URL appropriately, but for our purposes, this should be enough, and you'll see why later. Actually going from a string containing a reserved character to a %encoded string isn't that hard because the foundation framework, as always, takes care of the problem for us. So start by importing foundation. Now we don't need this project navigator here, so let's get rid of that. We're going to create an extension on the string type and add a method. Extension string. And the method is going to be called adding %encoding. And it's going to return a string. For the body of the method, we'll simply call a method on the string itself. So we'll say return self.adding %encoding with allowed characters. So this method takes a set of allowed characters as an argument. If it encounters a character that is not defined in the specific set, it %encodes it. To work with character sets in code, we use the character set struct, which represents a set of Unicode compliant characters. Now, character set, the type, has a static computed property, URL query allowed, that returns the set of characters allowed in a URL query. So we'll say character set dot URL query allowed. And you can see from the dropdown here that this allows us to specify different parts of the URL. So URL path allowed, host allowed, fragment, and so on. Now, this method returns an optional string, but we're going to force unwrap it for now. Let's test this method out by creating a test string. So we'll say let test string equal, and we'll put an opening and a closing angle bracket, a %sign, and the pound symbol, or hash. This string contains a few characters that should not be encoded as is in a query string. We can't pass it this way to a server. So to %encode it and make it safe, we'll call our method on it. We'll say test string.adding %encoding. Now, if you look in the results area, that's what it looks like. The method, or the string, is now %encoded and safe to use. Awesome. But this isn't all we have to do. A query string is constructed as a series of key-value pairs separated by an ampersand. Because a key-value pair structure is representative of a dictionary format, we typically construct our parameters for the query string as a dictionary. So let's get rid of this. We don't need this test string anymore. We know that this function works. We're going to create a new function, an encode function that accepts a parameters dictionary and returns a query string. So we'll call this func encode parameters in URL. The encode function is going to accept an argument of type string to any and return an encoded query string. So we'll say with parameters string to any, and this is going to return a string. Actually, since this is a very generic type signature, it doesn't actually provide any information, we'll say with parameters. And you know what? Let's go ahead and put that in the base name and omit that. So encode parameters in URL. There we go. In the body, we're going to start by creating an empty array. The array is going to contain tuple values, where the tuple will contain two strings that represent a key value pair. So we'll say var components equal string, so a tuple of two strings, and we'll initialize it to an empty array. Now, typically, we sort the parameters in a query string by their keys in ascending order. So let's create another array containing these sorted keys. And the keys and values are in this parameters dictionary. So we'll say let sorted keys equal parameters dot keys dot sorted by, and here we'll pass a closure that contains the logic, and we'll just say $0 less than $1. So here we're calling the keys property on the parameters dictionary, which returns an array of keys. We then sort the array by passing in a closure containing sort logic. Next, we're going to iterate over these keys and get the corresponding value out. So we'll say for key in sorted keys. And to get the value, we'll say let value equal parameters. And we'll use the key. And we know this exists because we obviously just got it from the parameters dictionary, so we'll unwrap it. Next, we're going to call a method query components with that takes a key and a value. This method is going to %encode the value and return the key and value pair as a tuple of strings inside an array. So we'll say let query components equal query components with key is the key and value is the value. Now, we obviously haven't defined this function yet, and this function is going to do most of the work in encoding a key value pair. Just to get rid of this error for now, let's define an empty method right below. So we'll say func query components with key string value any, and it's going to return a key value pair as a tuple inside an array. For now, we'll return an empty array. So now, once this is called and we pass in a key and a value, we now have an array of tuples containing the key and value %encoded. We need to get this in the format defined by the URL, which is a single string containing the key, an equal sign, and then the value. And that's really simple. We can say let encoded components equal. Actually, before we do that, we need to add these tuples to our components array. So after we get a query component using a key and a value, and we do it over and over again in this for loop, we'll add each one to the components array we declared at the top by saying components.append query components, or rather append contents of, since that's an array itself. And now over here, components at the end of the for loop contains an array of tuples containing the key and the value. So to get this into the format defined by the URL, we'll say let encoded components equal components.map. That gives us each tuple. And then we'll parse that and make it a string. We'll do that using string interpolation, and we'll say $0 equal $1. Now we've gone from an array of tuples to an array of strings. We still want a single string though, with each key value pair string separated by parentheses. We can call reduce on the encoded components array and define a combine function to do the work, but the standard library has a method that does just this. So we'll simply say here return encoded components.joined, and the separator here is an ampersand because each key value pair is separated by an ampersand. There's a tiny bit more work to do to finish this implementation. Let's do that in the next video. So ignore any errors here, which we shouldn't have any because we're returning an empty array. All right, on to the next video.